All right, we got a video over a practice worksheet that you'll be doing in class, but you might need some help as obviously Mr. Hughes is still not there. But anyhow, let's just go through it. This has a couple sneaky things, and it's got a really nice calculator practice problem that you might even need to come back and do this as you're getting ready for your AP exam, because by the time we get to April and May, you won't have done this for a long time. So here we go. So this one talks about it says how many oil wells and it will produce critical information in deciding whether or not to drill more wells. Here's the estimated total amount of oil recovered from 36 wells in this, wherever this place is, the Davionian, Richmond, Dolomite area in the Michigan Basin. I have no freaking clue what that is. I don't know, but I do want to point out it is in thousands of barrels. So 3 isn't 3. It's 3,000. All right, let's just keep that straight. And again, they tell us here again as they label it, and just got to be real careful for that. I don't think we've seen that at this point. That will not be the last time we see that this year. Might be a good thing to sneak in on the retest or something. The data is provided in ascending order. So they give us all the numbers, plus now they give us a dot plot. Now, this one says, what measures would you use to describe the center and spread of this data? Now, technically, you could use any measure of center of spread. Center is going to be mean, median, and mode, and spread is range, IQR, and which one am I forgetting? IQR, range, and standard deviation, excuse me. But anyway, the idea here is based on the distribution, there's a best one you should describe. Okay, because this graph is skewed to the right, or if you want to say it's approximately normal with this crazy outlier over here, that's fine. Whether there's an outlier or the data is skewed, you should use the median and you should use IQR. And justify your answer. And you want to say these are resistant measures of center and spread. Or you can say, that's the statistical way, you can say that they're not greatly affected or they're less affected by outliers or skewness. Okay, but that's the idea. If it was normally distributed or approximately normal distributed, not that this says it, but just to review, you should use mean and standard deviation. You say, well, what about range? Okay, range is fine. And if you're writing a FRQ question, just use the range. If they say which the best, or which one should you use, or would you use, if it's skewed or outliers, median, IQR. If it's approximately normal, mean and standard deviation. And the reason for mean and standard deviation, mean is much easier to calculate. And in the case they're approximately normal, they'll be about the same. Standard deviation is used because it uses all data points. Okay, find the 5-digit summary. Calculator time. So I went ahead to save time. I've pre-typed in all of these numbers. So that's, and I'm gonna go ahead. So if I'm back on it's stat, and then you can just hit enter, stat edit, and you plug in all of those numbers, and it goes way beyond that. But again, you can go ahead, you can pause the video and type those in. Okay, now what we're going to do is we're going to go to stat, and then we're going to go to calculate. And then we want this 1var stats. That's something we'll be using during this first unit. And then later we'll have to go back and use it again. And it's kind of confusing because it'll be such a long time between. Okay, now here's the nice part is just go enter, 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 and don't worry about it. We'll have to mess with that later, but not for this unit. Okay, the mean is 50.4 or 50.3947 or whatever you want. That's the sum of all of them. Don't care. That's the sum of all of them squared. I really don't care about that one. All right, these two. One of them is the standard deviation. One's called the standard error. The one that has that little sigma symbol, that's the standard deviation. We will use the S sub x later. Okay, then, oh, I'm sorry. If you'll notice the little arrow right there, that means there's more information underneath. So if you push down, 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 down till we get to the bottom, there's your 5-digit summary. The N is how many numbers you typed in. That's my 5-digit summary. That is a very common multiple choice question on the AP exam. And it's like, yes, please. Now, You should write them in thousands. I don't even know if I wrote those down in thousands the last time I made an answer key for this, because this is the type of stuff that I screw up because I don't do a very good job of reading the directions because I think I'm so freaking smart. I know all this stuff and I don't need no directions, but that don't work out so good for us. Okay, so there's my 5-digit summary. Another nice thing about the 5-digit summary, if you write them in order, you don't need any labeling. You don't need to list what they are. They don't need nothing. So that's all you do. That's a beautiful thing. And again, don't make the easy stuff difficult. Okay, are there any outliers justify your answer? Now, look at that one. That's an outlier, okay? But we actually need to calculate it this time. All right, so the way we do that is we're gonna use the 1.5 IQR method. So first thing I need to do is I need to find the IQR, which is 65,000 minus 35,000, because this is Q3 and this is Q1. So IQR equals Q3 minus Q1. What the heck, let's write this down. So that's 65,000 minus 35,000, which is 30,000. Okay, but now I need 1.5 times IQR. And that's, well, 30,000 times 1.5 is 45,000. Okay, now what I do is what I do now from this 1.5 IQR is I go to Q1 and I move to the left or subtract 1.5 IQR, which is 45,000. 35,000 minus 45,000 is negative 10,000. That doesn't make any sense. What does that mean? There are no small outliers. No matter how ridiculous of a number you get, and it's not going to be less than 0, it's not an outlier, okay? Then for the large outlier, I need to go to Q3. I needed to add 45,000. So what I would say, the small boundary equals 35,000 minus 45,000 equals negative 10,000. I ain't gonna worry about that one. But I'm gonna show my work and say, hey, I did figure it out and I know what I'm doing. The large boundary is 65,000 plus the 45,000. And that's 110,000. That is the cutoff. That is the large boundary for the outliers. Anything larger than that is an outlier. But now real quick, if it's that number exactly, if I would have had a 110 up here, that would have not been an outlier. It actually has to exceed. This is the boundary mark for the non-outliers, which does get confusing, but if it's a tie and it's right on it, not an outlier. If it's beyond it, so 110,000 is not an outlier. 110,000.1 is. I know that's really screwy, but we just need to make sure we know what's going on with that border. And in the AP exam, they will absolutely give you borderline numbers exact. There's no way they're not going to do that. They need you to show that you know what's going on. All right, and then draw a box plot. So, oh, wait, by the way, so we'd say yes, 157,000 exceeds the 110,000 boundary. Let's call it large boundary. Yeah, I probably should have made an answer key and worked it through with the answer key off camera, but I didn't have time for that, unfortunately, today. So the good news is I sound a lot less robotic when I do that. And so anyhow, and then draw a box plot. All right, so on this one, the box plot, remember when we do the box plot, we use the 5-digit summary to make the box plot. Now, also, I will tell you, I might have you freehand draw a graph, but the College Board's pretty much been doing the graphs with the grid. But we're going to go ahead. We need to go from 3,000 to 157,000s, and I'm going to go ahead and do it in thousands of barrels so I can write smaller numbers. All right, but I need to make this, and let's go from 0. I'm going to go from 0 to 200. So 100 is here, and 50 is here, and 150. thousands of barrels. Okay, don't forget that. Yeah, might as well just go ahead and get that out of the way. I probably haven't been able to chance it, but the number one mistake is not labeling the x-axis. Oh my goodness, it happens so much. All right, then what we do is make the scale first, then draw the box. Our students always want to draw the box first and then make the scale fit, and it does not work. You get bad scale. Also, the scale needs to be consistent. You don't just drop down these numbers from the 5-digit summary. You need to make a consistent scale and then make it fit. Okay, so this minimum was 3, and I go, you know, you're not going to move it over very far, right? Because this is 50 to 0. So 3 is going to be like almost on the 0, just a little bit to the side of it. Okay, and then 35,000, well, here's 25,000 would be here. And I'm not going to mark that because then I'd have to mark all of them. But 25,000's here, so we move over. That's about right. And it doesn't have to be perfect. It has to be reasonable. It has to make sense. Like 3 can't be a quarter of the way between 0 and 50. But I'm not going to get a caliper and measure it to the millimeter and count points off if it doesn't fit. All right, 47,000. 47,000 should be reasonably close to the 50, about as far as 3 was to 0, that 47 should be from 50. All right, that makes sense. And then 65, this would be 75, so 65 would be about right here. And then the 157, now I got to be careful. 157 now is going to be an outlier. So I need to draw that one as an outlier. So now that means I actually don't use this number for the box and whiskers. I have it for this. So where's the other whisker at? And the answer is it's the second largest number, or the largest non-outlier number, if you will. So that's right. Well, let's scoot that a little bit closer to 100. I just kind of connect those boxes, and there it is. Probably you'll be drawing a box plot. I will definitely give you a grid because the College Board's been giving grids to the students. Again, you look at this, it's not an artist, but everything is clean and it makes sense. So there's the box plot. Okay, and without doing any calculations, is the mean or the median larger? All right. So this used to be on the test every year. Now it just is sometimes, or it's a part of a bigger question. But remember that the mean is not resistant, the median is. So here's the peak, that's the mode. The median with the skew is going to be just a little bit to the right of this bump because it's skewed to the right. The median is just a little bit over from the peak of that bump. The mean, and it wouldn't be this far down, but I'm going to over-exaggerate the picture so I can actually see what's happening here. The mean slides down the tail more. So it says, which of these is larger? The mean, oh my goodness, the min, not min. The mean is larger than the median. Okay, and that's how we can tell without calculations. If they said justify it, you would say that the mean is not resistant and it gets pulled to the right with the tail. This one just said which one is it, so I'm going to leave that alone, but I'm at least going to add that tidbit. All right, I'm so sorry I'm not the first week of school.